Alright, bit of a help question here from exercise 1J, question 6e. We've got some pretty complicated functions here. F of x equals x squared minus 4x plus 3. That was fine. In part B, I think you had to show that it will only have an inverse if x is greater than or equal to 2. That'll keep it as a one-to-one function. And the inverse function you found out earlier on in the question was 2 plus the square root of 1 plus x. Now what we're trying to show is that an inverse function works exactly as we would expect it to do. If I take the function and put it into the inverse, or vice versa, we should end up just with x back at the end. So what we're going to do is we'll do the left-hand side of it, then we'll do the right-hand side of it, and we'll see that it doesn't matter which way we do it, we end up with x. So if I want to do f of the inverse of x, f of negative 1 of x if you like, then what I know is that the structure of this is going to look exactly the same as the f of x function. That's the outside one, f bracket. So I'm going to have something squared minus 4 times something plus 3. Now what's this something? Well, it's the 2 plus root 1 plus x. So 2 plus root 1 plus x squared minus 4 times 2 plus root 1 plus x plus 3. And what we're hoping is this will end up being x. Let's see if we can get it right. Remember how to expand one of these. First number squared, 2 squared, plus 2 times the first number times the second number, 1 plus x, all under the square root, plus the second number squared. Now you can simplify that yourself if you want to do that straight away, that's fine. I'm just going to keep going here and expand the other bracket. Minus 4 by 2, minus 4 by root 1 plus x. And again, you could just calculate those as you wanted to go. Could have put the negative 8 in there. But seeing as though I did it for the first one, I thought I'd keep going consistently. You'll see I've turned on my touch screen again, so you're going to find a few things popping up along the way. I've got to remember to turn that off again soon or it's going to drive me nuts. Let's persevere. So the first number there is 4 plus 4 root 1 plus x. Now a square root squared just undoes itself, so that's going to be 1 plus x minus 8 minus 4 root 1 plus x plus 3. Let's tidy it up and see what we get. First thing I'm going to do, let's just highlight the fact that this is plus 4 root 1 plus x and negative 4 root 1 plus x. They're going to cancel each other out, so that's nice. And we'll go ahead and work with our numbers. 4 plus 1 is 5. Minus 8, negative 3 plus 3, well, it goes to 0. So all that I'm left with is one lonely x, which is just as well because that's what we wanted to show. So we know f of negative 1 of x, or f of the inverse function of x, works fine. What about if we do it the other way? If I find f negative 1 of f of x, what will I get? Well, the structure is going to look the same as f negative 1 of x. It's going to be 2 plus the square root of 1 plus something. There's only one something to fill in. This time it's x squared minus 4x plus 3 that I've got to fill in. Minus 4x plus 3. And I've got to extend that radical sign to make sure it's all included underneath. Alright, let's see if we can make sense of this. 2 plus, let's just simplify what I've got under there. I've got an x squared, I've got minus 4x, and 3 plus 1 last time I checked was 4. Some of you will have seen it already. That looks like a perfect square to me. It's really just x minus 2 all squared. Now this is where you can cancel out a square root with something being squared underneath it. So it's just 2 plus x minus 2. Oh, lo and behold, 2 minus 2 would be nothing. And we've got x. So it doesn't matter which way we go about it, we end up with x. I hope that helps. Cheers.